Steve and Jonathan, thanks for joining. You guys want to quickly introduce yourselves?
After you, Steve.
Thank you. You're very polite. I'm Steve Dilley, and I'm the product manager for Aurora Gen AI.
And I'm Jonathan Katz. I'm also a product manager. I'm actually on the open source Postgres core team, and I've been involved in the PG Vector project.
Very cool. So we're going to learn a little bit about databases and generative AI. We get a 2-for-1 here. It sounds like, yeah. Okay.
Definitely.
Cool. So let's start. Let's start with. Well, we had our poll question up. I don't know if we want to immediately jump into answering what RAG is. We'll keep that poll going for just a minute before we get into the answer. But maybe we could start with, why would we even be talking about a database in conjunction with generative AI? Where does Amazon Aurora start fitting into the picture of generative AI? Maybe that's a good question to start with.
Yeah. Well, I certainly can answer that, and then we should talk about RAG pretty soon because it's important to understand that.
Yes.
Because that's what we're here to. That's the big story of the day. But why does a database matter here? Well, when you're doing retrieval augmented generation, what you need to do is there's vectors involved. So you take your content and you turn it into mathematical representation that can be compared within a database to find similar size vectors or more relevant content. And those all get stored in a vector database. And that's why Aurora is involved here. Aurora is what we're using as a vector data store.
Okay, so let me ask, when would you use RAG versus not using RAG? Or when does it come into play? When does it make sense to use RAG versus just a basic LLM?
Well, sure. If you just want to have fun and go out and ask silly questions about unidentified aerial phenomenon or things like that we were talking about earlier, you can just go out to ChatGPT and type things in and get kind of generic answers. But what RAG is it stands for Retrieval Augmented Generation. It's one of the most common things that we see companies implementing. So these foundation models like ChatGPT, et cetera, are amazing, but they're generic because they're just trained on public data. And they don't work well for applications that require access to your internal company business data, things like your pricing or customer information, things that are private. Or they also don't work well for data that is like really up to date. It came out after the model might have been trained. So what RAG allows you to do is add this type of data to the foundation model's dialogue with users. And just, to give you an example, if you had a kiosk that was based on a large language model in a coffee shop, and you went up and you asked it, hey, can I get a hot cappuccino for $5? The model, in this case, if we actually had done RAG with it, would actually know if the store was open, and it would know if you actually had a hot cappuccino on the menu for less than $5 versus that very expensive place down the street that sells hot cappuccinos for $8. So that's what RAG is all about. It lets you add your business data to it. But to do this is a laborious process. It requires lots of custom code to do this. And what we've built is a way to automate the RAG workflow and make it more affordable and higher performance. And to do this, what we've done is we've integrated two of our services, the knowledge bases for Bedrock, Amazon Knowledge Bases for Bedrock, which is our fully managed capability for automating RAG workflow from the data ingestion to the orchestration, and then the Aurora PostgreSQL database with the PG Vector extension installed in it. And this is where you put the output of the Bedrock models, those vectors that I talked about earlier, that will allow us to determine what is really needed that we want to augment the training of the model with. And if you have all this together, like we've done, now we're able to eliminate that custom coding work for our customers.
So,
Yeah,
Steve, can I ask real quick a question? You described a good case for RAG as I have a bunch of information that is not public information. I wanted to ask a really simple question here too. Even if it's public information, what if I'm would RAG be a good use case for if I'm dealing in a very specialized area, for example, like if I'm deeply interested in space-time, quantum mechanics, things like that. If I use RAG to give very specialized knowledge to an LLM through a vector database. Is that another use case that you see, or is it strictly,
No,
I can't get access to this?
I think you're absolutely right that it could add specialized knowledge too. So these foundation models are trained on really, really, really broad sets of data. Millions of GPU hours run, and this costs millions of dollars to build these large foundation models. But they're not trained on anything. So if we took our unidentified aerial phenomena, maybe that's not been trained that well into the foundation model, and you want to have something specialized for that. You could actually get your data sources on that and build a RAG workflow to get that model or to get that data and augment the training of a generic foundation model.
Yeah, Steve, you made a good point that I think is often overlooked when we think about LLMs. They're trained, and it's like on a point of time of the internet, or this large, all the millions of points that an LLM is trained on. It's at a point of time, and even if you think, some people would say time is a flat circle, but it's that point of time. So if you needed to update that data or add this custom data that AM was talking about, you would need to retrain that model. And just like you said, that's a very expensive and laborious effort. So sounds like that's where RAG comes in, where you don't have to retrain anything and just add specifically what you're looking for.
Yeah, building a foundation model is way beyond the budget of most companies. So
speaking of, Steve, we've got a question from chat that I think plays into that very nicely. Building foundation models, not feasible for a lot of people. Right. What is Bedrock? Right? Can we talk about Bedrock and how foundation models are at play in Bedrock?
Well, Bedrock is our it's our platform. It's our serverless platform, fully managed serverless platform for providing API access to foundation models. And so what's made Bedrock so great is it's serverless. You just don't have to leave it up and running all the time. It's serverless. You can use it when you want to. And then you get a choice of best of breed foundation models. Those from Amazon, but also from partners as well, that are part of it. So we're giving you like a lot of different capabilities within Bedrock.
And that's also key messaging on other pieces of AWS. We always try to convey, use the right tool for the right job, and Bedrock allows you to use the right model for the right job, the right size of model and everything. And I think that's part of its magic as well.
Exactly.
And so also Bedrock has features. You briefly talked about knowledge bases for Bedrock, which is, we've been talking about RAG. You can build a RAG kind of pipeline yourself, create your vector database and connect everything. But it's a little bit easier if you have a fully managed service to do that. And that's what knowledge bases is. Am I right?
Yeah, exactly. And it's a lot easier. And we'll be publishing, we've been working with customers even before we had the knowledge bases for Bedrock integration out with Amazon Aurora. And in about a couple of weeks, we'll be publishing actually one of our a blog with one of our customers, and you can see all the custom coding that went into it because we were building this before we had knowledge bases integration done. But it's still a perfectly viable way of building a RAG model, and I'm sure some customers will still want to do that using LangChain and other coding techniques to build their own custom solutions. Knowledge bases is a nice way to do it fast for less money.
So I wanted to ask, how important is the database in the vector database portion of RAG? Can we talk about how critical that is?
Yeah, well, certainly I think it's very critical being from the Aurora team, but the database is actually really critical, and it's critical to the performance. And there's really been a lot happening around performance of the vector databases. And I'll break it into a couple of areas for you. So first, there's within databases, there's indexing, and there's been indexing improvements in PG Vector, which have actually, compared to where we were last year to where we are this year, we've improved the performance by 20x. And this is what has happened with the PG Vector indexing, which is pretty impressive. So first, let me explain what PG Vector is again, because not everybody knows what that is. But PG Vector is an extension for the PostgreSQL database that allows you to store, query, and index vectors in Aurora. Now, you may ultimately have millions or billions of vectors, which could be terabytes of data that actually get built into your knowledge base. Aurora is the knowledge base if you're using that with Bedrock. and it can be quite large. So when you want to start doing your similarity search across all these stored vectors to determine what is most relevant to pass along to the foundation model to augment that training, how do you do that? So what happens is, you would have to, one way of doing that would be just to compare your user question, which would come in and be turned into a vector itself. You would just compare it to all the vectors in the database. Now, as you can imagine, if you have billions of vectors, that could be quite slow and you wouldn't have good response times. So that's where indexing comes in, and it improves the performance of it. And so there's been two types of indexes that have been supported with PG Vector. The original one was called IDF flat. And these index names, I don't know who made these up, but the inverted flat file index, or inverted file index is flat, I think is technically what it's called. And it's kind of like, I don't know, I've once heard of saying time is a flat circle. So it's probably like that or something.
Yeah.
But
Agreed.
what it works with is the concept of clusters. And so if you understand clusters, just make it simple. What happens is you take the content that we put into Aurora and you cluster it into similar types. So for example, if I were building a pet breed kind of chatbot or something that could determine the breed of your pet, you might have clusters set up, which are dogs and cats and turtles and hamsters and things like that, which would have happened when you were building the indexes. Now, if we came along and uploaded an image of my dog, who's not shown here today, but maybe he'll show up later, he's a black-mouthed cur, the algorithm would quickly navigate to the dog cluster, and then you would skip having to search through all those other clusters of turtles and hamsters, et cetera. So you can see how that would improve the performance. The newest type of algorithm, however, is called, and this is a mouthful, the Hierarchical Navigable Small World, the HNSW index. And the idea of this index is really, it's like constructing a graph so that you can move from vector to vector in the smallest number of steps. And so this is sort of like the game, if you've heard of it before, the 6 Degrees of Kevin Bacon, where you can navigate to any Hollywood movie by stepping through other movies that Kevin Bacon was in. And so it's kind of like doing that. And it turns out that this new HNSW algorithm is really, really fast. It's both simple and scalable, but it's also very fast. And our testing that we've done with this shows that this is about 20x faster across a range of workloads than what the traditional indexing method, the IVF flat that we were using, a year ago.
I mean, this is these concepts are so foreign to me. I'm a simple DevOps cave person. So I'm still enlightening myself when it comes to all of the phrases and words within AI workloads and things like that. And vector, I think it took me a while, but I realized two things, and please tell me if I'm right here or if I'm wrong. Two things that were very important when you're setting up a vector database. It sounds like, for me, when I think of a database, I'm thinking about, I need to optimize reads or writes depending on the workload. For a vector database, sounds like reads are the most important thing because it's serving as this layer that's going to be queried by your LLM model as it searches for answers. The other thing, vectors, this is like a numerical representation of your data, right?
Yes.
I was trying to really digest what a vector was, and it's just a long list of numbers that is usable by a model to reference certain parts of data in your database. Is that right?
Yeah, no, that's it. I mean, if you think about it, when I studied data science, I remember the first time I got into the coding of like, how do you do these image comparisons? It's like, I had no idea how this was done, but really the images, or we did it with handwriting recognition, just get decomposed into vectors. And of course, computers are very great at rapidly like comparing numbers together. And that's how you navigate to what is most close when you're doing a similarity search. But AM, since you mentioned you're a simple DevOps guy, I got something for you.
Okay.
Woo. So You're right that read performance is very important. Write performance is also important in building, but in building the vectors. But
Okay.
my simple thing that we've got for you as a DevOps guy is a hardware way of making the performance run faster. And so we've come up with it. We have a second performance development we wanted to talk about today too. And what we've done is we found a way to keep more of your indexes and the indexes and the vector data itself in memory. And of course, something in memory is much faster when you're doing comparisons than having to go to disk. I think we all understand that. And that's what the feature we have with Aurora that's called Optimized Reads. And it's available on our R6 GD instances, which contain non-volatile memory. So Optimized Reads, what it does for these vector comparisons is it uses this extra memory, which, oh, by the way, is about 4x the amount of RAM on the instance, as a tiered cache. So when your vector data, if it's big, it exceeds the size of the memory, we can continue providing memory-like performance for more and more data than you would be able to if you were not on this type of instance. And here again, we're seeing great performance uplift. Our benchmarks are showing on a 1 billion vector data set that doesn't fit into memory. We had to make sure it didn't fit into memory. It would run about 9x faster than when you were using our instances that did not have the non-volatile memory cache on it. So this can give you faster performance for your queries, but another way to look at it is it can also save you money. You always have a choice with performance. It's two sides of the same coin. Do I want my queries to run faster, or do I want them to run at the same speed and I can do it on a smaller instance? And so it could save you like 75% of your computing cost as well by using something like this.
I love that.
Is that good enough for you? It's a hardware way.
That's perfect. That's great. Jonathan, we haven't heard much from you, and I know we're waiting to, I was promised a demo. So
I want to see this in action.
You're our person for that.
Yep. The promises shall be delivered. So today we're going to demo, we're actually going to demo a couple of things. And I think first is just pictorially representing what RAG is. So I think Steve did an awesome job explaining it and the different use cases where you'd want to use RAG. But basically, RAG is broken down to two components. First, there's that 1, 2, 3 in this diagram where you have your raw unstructured data, probably in your S3 bucket, and you turn it into that list of numbers, as you call it, AM, to get that numerical representation, and you store in your vector database, here being Amazon Aurora. Once you have that data loaded, then you begin part 2 of RAG, which is someone comes in, they ask a question, and they're able to augment the response by querying your vector database and bringing it into the foundational model to give you an answer. Simple, right? But there are some things we have to do to set it up. And what's nice is that with what we're going to learn today with knowledge bases, we're going to have an automated pipeline to be able to fully manage this workflow. So to get started, the first thing that we need to do is we need to have a database. So what you can do is you can come to RDS. Well, actually, I'll click up real quick. You click Create Database. And today we're going to create an Aurora Postgres database. And I'll show you some of the options that we're going to pick. As I've mentioned, I'm active in the upstream Postgres project, so I always like to run the latest of everything.
Sure.
And we'll give it a name. Let's call it like Bedrock Demo. Now, there's a few things that we're going to want to do here. Right now, I'm going to click Manage My Credentials with AWS Secrets Manager. So Secrets Manager is a service that securely protects your credentials, so you're able to use them in different services and be able to have a secure mechanism for storing them. We're actually going to work with Secrets Manager a little bit later in the demo, but I did want to check this box here. Now, Steve mentioned Aurora Optimized Reads. In order to get access to Aurora Optimized Reads, you do need to select Aurora IO Optimized from the console or from the API or from whatever tooling you're using to be able to create your Aurora cluster. And the Optimized Reads classes are available here. You click Optimized Reads, so you can see those GD instances that Steve was referring to. Today, I'm going to be using Aurora Serverless V2. So Aurora Serverless V2 scales with your compute workload. So if you're relatively idle, you're not going to use that much compute. It's going to go to a smaller size. And if it's very heavy, it's going to scale up to be able to support the amount of workload that's coming through. The last key piece that I just want to call out as we go through this is enabling RDS Data API. Data API version 2 had its GA in December, and it's going to be the gateway that we're going to use to connect our Bedrock foundational models to our Aurora databases. So you do need to enable this when you set up, and then you can go through and pick other various settings that you want to do to configure your cluster. Now, it can take a few minutes for an Aurora cluster to create, so I did go ahead and do that. But as we're doing that, one thing that we're going to need to set up is we're going to need to be able to set up a secret. Now, we're going to create a separate user when we set up the secret because we try to follow the principle of least privilege. The initial user that you have in your Aurora database is great because it is your super user, but because we're giving access to another service to be able to connect to your database, we do want to use a database user with reduced scope, so that way they have minimal privilege. In this case, I'm creating a user called Bedrock user. I'm giving it some secure password. And I'm going to make sure I assign that user to that demo database that I created. You then give, well, you don't save it to the browser, but you then give that secret a name. It could be whatever you want, like production, Bedrock user, however you want to call it. Yeah. And you click next, and it creates the secret. Now, you also need to make sure you create that user initially in your database, so that way you have that mapping between Secrets Manager and your Aurora cluster. Now, the final bit, in terms of this setup, is you need to have your secret ARN. And that secret ARN you're going to pass into Bedrock when you're creating the knowledge bases. So I'm going to copy that real quick. And actually, I'm going to show one cool thing as we do that. When you enable Data API on your cluster, you're actually able to use this thing called the query editor from the console. So you're able to query everything directly. So we're going to connect. And I'll just run something. Just run this query. You can see, the query runs, and I'm able to immediately get access to my database, which is pretty cool. From there are some steps that you need to follow to set up to basically prepare your Aurora cluster for the integration with knowledge bases, which you can find in the documentation. I actually, I have all that SQL available here. And just copy and paste. I actually already ran this, but I just wanted to show you what it was like to copy and paste something from my terminal window.
Yeah, I was going to say there are rows already down below, so you obviously have already put something in your database.
Yeah, I'm trying to show baking the cake while eating it at the same time.
Perfect. Yeah.
Because I think what space-time is a continuum is I think we keep coming back to.
It is a flat circle.
Yeah.
Flat circle. There we go. Yeah. So let me back up 1 second. So now we created our database, we created the secret. We're ready to merge it all together with Bedrock. So when you go to the Bedrock console, we go to something called create knowledge base, or we go to knowledge bases, we click create knowledge base. You put in the name of the knowledge base. What's nice is that with knowledge bases, is a way to automatically configure your IAM permission, so everything is set up automatically. So you can have that, pre-configured for you, or you can add your own IAM role. Now, as you mentioned, we need to be able to pick a location for where we're storing our raw data. In this case, an S3 bucket, and I have an S3 bucket already available, aptly named Bedrock Knowledge Base Demo.
And Jonathan, just so our viewers are aware, when we talked about our own personal data, or that extra data, the updated data, the manuals or whatever that we wanted, say a bunch of PDFs would be stored in this S3 bucket that you're pointing to, something like that.
Yeah. And then from there, what you can do is you can select, what we're doing is we're setting up that first part of RAG, basically the step 1, 2, 3. So from there, we're going to, you pick the embedding model that you want. You choose which vector storage system you want to use, in this case, Amazon Aurora. And we put in the information that we've collected throughout, we've been building up throughout this demo. So your cluster ARN, database name, table name, etc. Once that's all set up, you can create your cluster. And effectively what you have is you have a knowledge base. You have all this information synchronizing. Now, what I did for this knowledge base in particular was I actually uploaded a document around Postgres 16. And the reason I did that is that Postgres 16 released in September. But the last time these foundational models were trained, Postgres 16 wasn't available. So this makes it a natural use case for RAG because we're augmenting that information. And the way I can test that out is knowledge bases does have a way you can select a foundational model to test. So I'm going to pick a Claude 2.1. I'm going to attempt, there we go. I'm going to click on it. And I'm going to ask a question like, what are the highlight features of Postgres 16? And we can test how quickly I can type. So while it's looking that up, I'm going to spoil it a little bit. If I go to the release notes, we can see if I zoom in, here's some of the highlight features. There's features around logical replication, some query performance features. And we go back and we see, there we go. We're able to find that within the database. Claude was able to figure that out through an augmented query. And that's really cool. And that's the power of knowledge bases, is that we're able to have that all managed. Now, I'm gonna take a risk in a live demo, which is I'm gonna try to do something I haven't done before, which is add some more augmented information. So there's a blog post that we had talked about earlier around improving the performance of your vector searches using Aurora optimized reads. I created a PDF of that blog post, and I'm going to upload it right here, right now, hopefully. Yep. Let me make sure I select that correctly. All right, so it uploaded. It's in our S3 bucket. And now I'm going to synchronize that. So what I'm going to do, even though we have an auto synchronization capability in knowledge bases, I'm just going to manually sync it to make sure that we have everything up to date. So we can see that it's synchronizing. And while it's doing that, I do want to show off one more feature around Aurora machine learning. Oh, never mind. That happened so quickly, I might not have time to do that.
And really quick, what that sync was reading that new document you just uploaded to that S3 bucket. And as AM and Steve were talking about earlier, the PV vectoring is turning that into ones and zeros to add into the vector database to augment the search from the LLM. Is that right?
Yep, that's correct. So the one thing is the embedding model, in this case, Titan, is turning that into vectors that we're going to put into that database.
Okay, so yeah, the embedding model is what's turning those into ones and zeros for the vector database, right?
Correct.
Is that what? Okay, gotcha.
That's exactly what happened. So if we have time for one more quick example, let's see if we got that additional information. And we can ask a quick question around. Let me add a data source. Well, we're going through the live demo issues. So
we are also getting yelled at by our producer Jonathan that we are over time. So,
alrighty.
I don't know if you can maybe just give us one last thing. If I want to get started, for example, if I want to go start using this today, what do you recommend? How do I get started? Maybe.
Well, just like we showed today, you first get started by creating an Amazon Aurora database. You have some data in an S3 bucket, and you go to Amazon Bedrock, the knowledge bases console, and you tie it all together. We also have a wonderful blog post on it. Well, I think it's wonderful. Others can decide. Build generative AI apps with Amazon Aurora and knowledge bases for Amazon Bedrock.
All right. Thank you so much, Jonathan and Steve. But unfortunately, we've got to run to our next segment. But we appreciate you both being here and hope you'll come back.
Great. Thank you. Thank you, and thank you, Jeff.